really stacked the docket today. So excited to hop into it. I'll give you all about 30 seconds to make your way to the front, and we're going to get started.
And then one other helpful thing is you can just scan this QR code here if you want to pull up the slides on your phone, and then you can follow along.
Awesome. Let's get into it. As a quick reminder, if it's your first time, my name is Reed McCrabb, co-host of Hack AI, and I run a company called Linked, an applied AI company, and we're focused on go-to-market agents.
And my name is Bryce Miles, other co-host of Hack AI. I'm the CTO of Adrenaline Interactive, and we do product placement in video games.
So the docket tonight, super stacked. We are blessed to be sponsored tonight by PostHog, supporting this event, passing out some cool merch, and we'll have Kliment giving a demo. We then we'll have Sam Troyer, a lead engineer over at AutoHDR, really exciting AI startup here in Austin. And then lastly, Lascari, just one of the most talented AI developers I know. We're gonna get hands-on, learn what they're building, kind of see how they think about building agentic systems. And then the rest of the night's gonna be yours to vibe code, meet cool people, eat some more pizza. Yeah.
Right off the bat, just want to give a shout out to PostHog for sponsoring us tonight. If you've never used PostHog, they are an awesome product for product analytics. One of my favorite features is their session replay. If you just do one line of code in your web app, it can then watch, or you can then watch back all of your user sessions and understand how your users are getting through your application, where they're succeeding and where they're getting lost. Really, really helpful for lots of different flows and just a really easy, awesome product. So check it out.
I also want to shout out our drink sponsor, Avro, and they actually just came out with a new formula. So their thing is they have GABA in their drinks, which helps folks focus. So it makes a lot of sense for the group here who's managing multiple agents, writing code. Stop by the Avro table if you get a chance. Cool. We're gonna go right into AI news. I think the big thing that happened since our last event was the Terafab announcement. And this is essentially Elon kind of starting to pull his companies together. I believe this deal is between SpaceX and Tesla. Maybe xAI is involved as well. But essentially going to be like 10x the footprint of the Gigafactory. They're at least going to be starting here in Austin. I believe the whole thing is going to be built here. But just really exciting, to be in the AI space, probably the AI hardware space, especially here in Austin, and something to keep an eye on.
Then one of the other more exciting things that happened pretty shortly after our last Tech AI was Project Glasswing getting launched, as well as the mythical Mythos model. So if you guys missed this, Anthropic, one of the leaders obviously in the space, while they're in the middle of getting a lot of backlash for throttling usage limits, was like, here, we have this internal model that 40 companies can access, and it apparently solves all the problems in the world, or helps discover a lot of them. And it's just a really, really cool, exciting thing that's going to potentially come out. But right now, it's just, we know what researchers are saying about it. Some of the more impressive things to me are it's found a bug that was like 28 years old, which is kind of interesting. So we'll see how this changes cybersecurity and a lot of stuff in the future. But it's run by the Mythos model, which is apparently now too dangerous to release to the public, but eventually we'll get there. Anything else you want to add? Then conversely, whenever Anthropic does anything, OpenAI is going to do the same thing. So their version of it's called Project Spud. They also have some applied cybersecurity use cases in it. It's expected to be released as either GPT 5.5 or GPT 6. Pretty similarly to Anthropic's model, it's apparently outperforming a lot of benchmarks. but it's also kind of one of those like hypothetical things, and you apparently either know or you don't know yet. So exciting to see this stuff around the corner, but it's not out here yet, so we'll have to wait and see. And then lastly, one of the more controversial updates was Claude Opus 4.7 shipping April 16th. Not sure if any of you guys got a chance to use it or anything yet, but at least in my perspective, it's been a lot worse than 4.6. Normally when the model number has gone up, it's normally just meant, oh, this can help me solve some of my problems or something like that. For my own personal testing suite, I have like 50 past coding challenges that I've solved using LLMs. And whenever a new model comes out, I try and test it against all of those and see if it can one-shot fix the issue. Every time I had done this with like the newer models, it's always done better than previous models. 4.6 was able to solve 40 of the 50 total problems. 4.7 for some reason could only solve 32 of the 50 problems, so it actually like provenly degraded, at least in my use cases and stuff. A lot of other people online found pretty similar things, so it kind of at least heralds the end of the subsidization era, and that API usage is going to be a lot more common now. Subscriptions are going to be a little bit less valuable, and people are going to be pushing us more and more towards these more expensive frontier models.
Just to add to that, I haven't done benchmarking between 4.6 and 4.7. I'll take your word for it, though. What I did notice is with Opus 4.7, like the auto mode in Claude Code now works. So you can kind of just rip through larger projects without having to accept tons of stuff. So that's been useful for me.
And then now we're gonna take a quick little break to do a Kahoot on the current events. Not sure if any of you guys have played this before, but essentially it's
New segment here, so bear with us.
But essentially it's an online quiz that if you just go to this link, scan the QR code, everyone in the room can join and then play around with us. We also put together a little prize bundle here. So we got some nice PostHog stickers that reads modeling for us.
PostHog sticker kit, pretty cool.
We also got some Avro merch. Also pretty awesome.
Avro merch, linked tee. These are hot off the press. And we're gonna go winner takes all. So if you win first place, you get the whole bundle. Cool, cool. Dakota AI, welcome. There's some fun characters. Awesome. We're at 27, 28, 29.
Gonna give it just 30 more seconds here.
Don't add your agents.
Or conversely, figure out how to add an agent really quickly that will do this Kahoot. That'd be cool.
Cool.
All right, gonna get started. Sorry if you did not make it in. Opus 5.0. Oh, everyone's screwed. So then this is the title one. Yeah. How much did NVIDIA pay to acquire Grok, their largest acquisition ever? This isn't actually like Grok, like xAI's Grok. This is Grok who helps make some more hardware type products. A little confusing, but
Inference Grok.
Inference Grok, sorry. $20 billion.
20 billion. Most of you knew it. Pretty impressive. Which NVIDIA CEO declared, "We have achieved AGI" on the last Freedom podcast? Okay. Which one?
Going to throw some softballs in there.
Jensen Huang. That's actually crazy you said that. Question 3. What is the AI agent with 145,000 plus GitHub stars that manages email, automates workflows, and runs locally on your machine? Answer is OpenClaw.
You guys are killing it.
Project Glasswing helps find critical software vulnerabilities. What is the name of the unreleased model powering it? Who's paying attention? Claude Mythos, good job. Why did the Pentagon blacklist Anthropic and designate it as a supply chain risk? Okay, we're getting political. Great.
My OpenClaw bot made this, by the way, so probably would not have included that one. It can use Kahoot.
They refused to allow Claude for autonomous weapons or mass surveillance. 35, got it right. You guys are dialed. DeepSeek V4 is a 1 trillion parameter model. Which domestic chip suppliers did DeepSeek give early access to instead of NVIDIA? Wow, that's a good one. Huawei and Cambricon, is that right? Tricky one. What is the name of Elon Musk's 20 billion plus AI chip facility announced in Austin? Most got it right. Answer is Terafab. OpenAI's record-breaking private fundraise now exceeds how much? Answer is 120 billion. Wow. Tough question. 3 questions left. Which company recently joined Musk's Austin Terafab mega project to add serious silicon manufacturing capability? Okay. Answer is Intel.
2 more questions.
According to JLL's 2026 outlook, which state is projected to become the largest data center market on Earth by 2030?
Much
That's us,
like
baby. Final question. Avro drinks are powered by 200 milligrams of which clinically tested, naturally fermented ingredient? Pharma-GABA. Most you got it. Awesome. Let's see. Who's our winner here? Nanya.
No, that's there.
Oh, whoops.
Been late.
Okay. Matt Gia. Let's go. Orly's walking up. Are you Matt Gia? Okay.
Good job.
Yep. That's number one. Let's hear it for Matt Gia. So that was a fun segment.
Next time we'll make that a little bit shorter. But also just going to go back here for a second in case anyone wants an opportunity to get the slides. Also from these slides, you can then get to any of our presenters' slides as well. And then, thank you guys for bearing with us. First up, we are going to have Kliment from PostHog. So if you could all give me a warm welcome. He's going to show us a lot about product autonomy. No clicker.
What a fun game, huh? All right. My name is Kliment. Some of y'all know me. I'm in the scene here. We have a pretty good community going on, and the more you show up to events, you start seeing more and more familiar faces. And to be super frank, I love Hack AI. It's probably my favorite collective of technical-minded folks in town, so really happy to be doing this together. So big shout out to Bryce and Reed. And thanks everyone for coming. We'll talk a little bit about product autonomy, which is a huge push industry-wide. You've seen it, you know, an agent that does your SRE, you've seen an agent that approves your PRs, and you've seen so many of these application layer level technologies that are automating the boring stuff that humans don't want to do anymore. So with that, I want to just say it's happening. The product autonomy push is real. You have an AI code reviewer in terms of CodeRabbit or Greptile, to name a few. You have Rootly and Incident.io building SRE agents that live in your CI/CD pipeline and maintain everything that your application does, from the observability layer all the way to the user. And my take on this is that there's another automation coming up. And this automation, you know, Claude, make no mistakes, is not Claude in my personal application here that I'll demo. It's based on OpenClaw, but I'm making a statement that I believe the code-based maintainer will eventually be, or is about to be, an agent as well. And there's nothing really gonna stop or prevent that from happening. 4 out of 5 PRs are just ready to be approved by an agent. There's just no need for even the most skilled senior level engineers to be involved in fixing some, not necessarily trivial, but some pretty mundane and pedestrian error that users end up facing once the application scales, whether it's because of load or just code level logic. I think there's plenty of opportunity to outsource or delegate all of this work to an agent. And with that, kind of opens the opportunity to introduce the maintainer. So I built my own maintainer for my side project, which is based on OpenClaw and an code orchestrator, so something that just very diligently manages multiple agent sessions. One example is Pi. I think Mario Zeschner did a fantastic job introducing the world in the most minimal way possible of what it takes to orchestrate or delegate the orchestration of agents versus a human just having tmux up and just paying attention on every window possible, which just to click enter, I think that's probably not a good use of anyone's time. The next layer is PostHog. PostHog, I'm so glad that Bryce and Reed mentioned a little bit about it. There's quite a few features that PostHog offers as an SDK, really. It's a set of dev tools. So I've picked out logs and feature flags, which are the two features, in my opinion, that really provides the solid ground for the maintainer. So the maintainer having access to error logs or some kind of traces of usage, and feature flags to be able to quickly deploy something and present it to the user in a manageable way. So that it's perhaps not universally deployed. A feature flag is a modality of deploying features whereby only select users are exposed to said feature. So if you have a cohort of users segmented by age brackets or just some other attribute related to their usage, you can deploy a feature behind a feature flag that only they get to see. Very popular since the 2010s with A/B testing and experimentation. Codex is the harness that I'm using. I do have a lot of appreciation for Codex, and I think GPT 5.4 is doing a pretty good job maintaining a product. The Cloudflare tunnel is essential. Think of it this way. There just needs to be a webhook that triggers OpenClaw to get going and wake up and be like, okay, there's an incident, there's an error here. Think of it as just like a trigger to expose OpenClaw to, let's say, the PostHog MCP, for instance, with all the errors. And the stack of this maintainer is just the TypeScript stack. And the side project itself, no different than what you've already seen in terms of code or deployment, just Next.js and Vercel, which I think is a pretty minimal and well understood these days. Like, it's not complicated at all. So I'll get to the demo. I hope I have enough time for everything. And just to point out, the OpenClaw is triggered by an error, a usage error in the application, a code level logic error, which throws a 500 error. Then through the tunnel, I've built a bridge for OpenClaw, which we'll see what that looks like. So I'll gladly demo all of this. Maybe I should also join the Wi-Fi so that I can access it. No, I think about it. That's a lot of Wi-Fi here. Got it. Yeah. No. So anyway, what? Yeah. So once the OpenClaw is able to read the logs from PostHog and also use the same MCP to ship the feature flag and instrument the application in such a way that that exact user that has caused this error or received this error. Oh, okay, good. Okay. Yeah. No. Yeah. No problem.
Anyone got a hotspot?
Actually, yeah. You can probably just use my hotspot here. Okay. I'm glad to get on the Wi-Fi here if I'm in. So then the open claw is going to go through a process of reasoning and then create the fix, ship it, show it to the user, present it in the UI, and then complete its resolution. The claim that I'm making here is that all of this can happen before the request times out, which is a huge reason to embrace product autonomy, because in a highly competitive landscape where somebody else has built just as robust of a product as the core services that we use, the true the true winners emerge based on reliability and maintainability of these products. And there's no coincidence that reliability agents, and in my personal take, a maintainability agent is essential to provide that. And I'll show also what that looks like. This might get a bit too technical, but just so you know, it starts with the user. The client is, thanks to PostHog, able to really quickly pick up any changes in the front end, or if there's some kind of trigger. That's what we take advantage of. It's really essential. OpenClaw is exposed, which I'll also demonstrate how we can see it pick up the error and fill up the context to eventually solve it and then ship out the fix. And with that, I'll just go to the demo. These are some screenshots in case something fails, but just super briefly to give you an idea of what to look for. We'll trigger a controlled 500 error, which is a server error. So then the request will keep going until the fix is issued, or timeout after 5 minutes if there's no fix available. And in our case, it's just going to be a data type error. So the text field, the field is going to expect an integer. We're going to pass it some kind of non-integer, and it'll cause this error and handle it. So then this, what I call the OpenClaw bridge, is exposed. So we'll be able to verify the incident information from the request ID all the way to the resolution steps. We'll show also what PostHog looks like as well when a feature flag is created automatically, what the logs look like when the HTTP request comes in and the incident is caused. And then this is an extra bonus here for a PR, which we won't really see, but I can show other examples of what that looks like. So without further ado, just verify here. So this is on my side project. I just added a route here. We'll add we'll trigger a request here, and we'll be able to verify in PostHog that the request indeed shows up. So if you're not familiar with PostHog's UI, it's very smooth. I have two tabs up here, logs and feature flags, the two features that I'm gonna use. So I'll kind of prepare the logs here. So the crowd, I'm sure, is familiar with logging and observability. You're about to see a stream of little checkpoints from calling the endpoint. So when I put in, say, 420, that's an integer, so I'm expecting to get a 200 response, which is accepted by my backend, and I should be able to see live demos. Yeah, HTTP request completed. So this is just a successful call, API call. So now if I say 4/20 or something, that's no longer integer, I expect to see, boom, a 500 error. So we caught the error, our system is investigating, hang tight. And here's the request ID. So up here in my OpenClaw bridge, I'm gonna see this exact request here. So 770, C770, and then all of the steps that it's taking to resolve it, which it's still underway. And you can see that in the logs now. So this red one is HTTP request return server error, incident received, OpenClaw investigation started, fix ready, flag ensured, which is all of the steps that it's taking. And you're gonna see that in something like a minute, it is able to ship out the fix against the flag. And then the user will eventually just see the resolved. There it is. So fix deployed, click below to retry. And then it handles it. It still kind of prints out like a 500, but it's able to handle this with the fix. And the way you can see that is there's this 4 flags that it created. Let's look at one of them. So it basically creates a new flag with a new ID where the fix is shipped and presented to that exact user. Every user in PostHog is a anonymous UUID unless they provide consent. So I'm guessing that there was just like multiple sessions or something like that I have open, or it registered for some reason. It's hard to make a fun infra demo, but I hope I kind of triggered some of your creativity to think about the data layer, and most importantly, the way you deploy applications. It's changed a lot in the last 5 years from the days of containerization and some very elaborate CI/CD pipelines to a point where you just have a bunch of agents that you delegate some of the tasks, and maintainability of a code base, in my opinion, makes no exception. So this is all possible thanks to the ease of use of PostHog, not necessarily the product that they offer, but mostly these very specific features here that we're able to really quickly have the client interact with. So client being the browser and the user going through the steps without having to deal with any refreshing or any like closing the window, like clearing the cache and all that. All of this can happen basically client side. So with that, I think we can go to some questions if people want to ask. Yeah.
So for managing feature flags, if every fix is a feature flag, then and it's personalized per person, then I imagine it's going to be very cumbersome to manage in the future, right?
Spot on. So I definitely urge you to not think about this is like I won't be selling this product, or like I'm not trying to make a claim that this is the way to really build a complex system that's able to handle everything. You'll see me, even in my demo, I'm gonna go in and delete some of these flags just because they're not needed. And obviously there's a graduation moment of something that's a flag to like a PR that makes it in the code base.
Yeah, I think this is like the first pass, right?
Right.
Like,
Yeah.
If for triage.
Yeah.
Get something.
Exactly.
There.
It's to save the request. And my example really comes from let's say that every service or the majority of exchanges or transaction online will happen between agents and some kind of service. So if you're competing against several other services to provide the best news API, the best financial, ticker price API or whatever it is, there's a high chance that every request you get, you compete with your, competitors for. Like, you can't afford to lose. That's kind of a dystopian future, but you can't really afford to lose a request that's been made to you, because if you're effectively losing a sale at that volume that agents are expected to operate. So my claim is, you've gotten the request, don't lose that. Don't error out. Keep the spinner spinning, and then resolve it before it times out.
Yeah.
Hello, I was wondering, so in traditional software development, you have the SDLC, and then I was reading about the ADLC, the Agentic Development Lifecycle. Is that essentially what this is illustrating or demonstrating?
Yeah, I don't see why it wouldn't. I think it's a broader question around what, if anyone here knows what the future will look like in like 6 months to a year, I think that would be someone who, there is someone, I know there's at least one person in the audience that knows what the future will look like. But it's really hard, and we're going off of some assumptions, even if it's in agentic engineering and that big push. Just think about 6 months or 12 months ago when people were like, oh, I use, this model in this way, and then I have this other thing, I have these workflows, and no, people are just competing on the way they have their IDEs set up. Fast forward now, IDEs are almost obsolete. You just, it's all about how efficient your harness is, and that's just, it's changed so fast that it's hard to make, honestly, a claim that it's the right way of doing things, but it's certainly a way of having the engineering minded people or the product minded people focus on frontier aspects. Even I have a lot of respect for marketing people as well, because at the end of the day, if agents can sell to people better than people can sell to people, I think we have more of a societal problem. But I hope I answered your question.
Cool. One more question.
Yeah. What's the difference between this and just Sentry finding bugs and having an agent pop up and fix them? I mean, it seems kind of similar.
Yeah, 100%. I'm glad you mentioned Sentry. And well, first things first, this is all free, OpenClaw. The idea of OpenClaw is that the idea of my OpenClaw is that it's my OpenClaw and it's my maintainer. I don't know for anything else in terms of observability, whether it's the error logging from Sentry or PostHog or your favorite logging instrument of choice. That's totally totally in your favor to adapt to your stack. Whether it's the question if it's going to be an agent or a human, I think is already heavily drifting towards agent. And if Sentry's agent, which lives somewhere in your CI/CD pipeline or something like that, is something that you want to bring in or base your entire application on, that's also totally fine. My vision is that my OpenClaw is going to be maintaining my side project while also doing a bunch of other things, and just have some of this context across basically my second brain or my dedicated associate or something like that. So in a sense, it's a trustworthy system where I would like to also prompted eventually like, oh, who was this user? Just get on my Telegram and ask, hey, who was this user that saw this error? Like, have they consented, like their email? Do we know something about them? And just have access across systems, which I don't know if I'll allow the Sentry bot to have access to my Postgres database, for instance. That's something that I probably wouldn't do if I were to architect a stack. All right.
Awesome. Thank you so much.
Thank you, guys.
And I'm actually sitting next to our next speaker here. His name's Sam Troyer. Really talented engineer. Works at AutoHDR. Is that me? Works at AutoHDR where they do real estate photo editing with AI. And is really just solid in his understanding of infra and serving AI models at scale. So he's gonna have a lot of value to share with us.
Hello. Yeah, there we go. All right, can we see that? No. Where is it even supposed to be? Oh yeah, it's over there. It is not working. Not showing up. Did I do something wrong? Plug it up, plug it back in. Oh yeah, go for it. Figuring it out. All right, while we do this, just a little bit of background. So I am head of infrastructure at AutoHDR. We process somewhere in the order of about 30%-ish of all real estate listings in the United States. We edit using an AI model, and then we also have a number of other services. So this talk is basically just going to be about how to properly orchestrate a number of services at scale, and the challenges that we've faced therein. So the way that we started out was essentially just a monolithic inference job. So for each photo shoot that comes in, kick off a Kubernetes job. That Kubernetes job then runs sequentially every service within the pipeline, right? So there's about 12 microservices, and then the core inference model that runs. There's a lot of problems with the way that this architecture works. Overall, it actually works quite well, right? We're able to scale to about 100, 150,000 photos a day using just this architecture. So it actually works relatively well. But there's a number of problems, right? The first is that deployments take forever, right? If you change one service, you're then rebuilding and redeploying the entire container, which it's a gigantic container with like 3 different models, GPU-based models, on top of then the core inference model. So it's a total pain in the ass to redeploy once you make any changes. The second problem is basically just that it's really difficult to maintain, right? All of this is just one gigantic Python file that gets run, and then there's a bunch of different imports from around the repository. So it gets really difficult and really messy once you get up to scale, and you have a number of engineers working on it. There's a number of other cons that I wrote up there, but that's kind of like the 2 big ones. Another ancillary disadvantage is just that it takes up a ton of memory. So each one of these containers can peak at like 64 gigs of RAM. And again, if you're processing, 100, 150,000 photos a day, that's like, a couple thousand photo shoots. So that can get really, really bloated really quickly. So I rebuilt that into a number of microservices, right? So there's about 12 microservices that we run within the cluster. Each microservice is its own separate deployment with its own separate HPA. The primary inference job container that's kicked off when the photo shoot is submitted basically just acts as an orchestrator for all of these different microservices, right? So you take all of the different services that you're running, you put them all into separate deployments, and then you're able to scale it that way. One of the main problems with this setup is that when you're a company like ours, and now we do 250, 300-ish thousand photos a day, the traffic is really bursty. In the morning, real estate photographers are taking pictures of houses, same thing during the day. And then at night, everyone gets on at around the same time and just starts hammering the service, right? So you can be at literally like 0 photo shoots 1 minute and then 50 to 100 photo shoots the next minute. So how do you properly scale that and have quick turnaround, which these customers expect, without spending a ton of money on these deployments? The answer is that you have a really thin router. So on top of each individual deployment, you have a router deployment. That router deployment essentially, well, obviously routes the request to each specific microservice, which is kind of obviously the point. But then the other thing that it does is that you're able to, on top of doing retries, on top of doing, different fan outs, et cetera, you are able to capture metrics from each one of these microservices and then scale up that HPA as you need it, right? So let's say, all of these microservices are running sequentially. Let's say you get 50 photo shoots all in at once. You can then say, oh, first microservice has 50 requests in flight. Let's scale up the next 2 microservices accordingly, and then just do that all the way down the chain. You do that using Keta or any other basic Kubernetes orchestrator. So that's the basic idea, is that you have kind of a centralized request broker that you're then able to scale up each individual microservice accordingly, according to traffic. And so that way you can handle very bursty, very kind of unreliable traffic, still have decent reliability and not pay millions of dollars to AWS, which is a good thing. So that's the basic idea, that you have kind of independent deployments for each microservice. You have the advantages of actually maintaining slim microservices per job, but then on top of that, you're able to build kind of intentional, intelligent routing layers so that you can scale up those deployments accordingly. So that's kind of like the general basics of how our kind of microservice architecture operates. But a specific example of this, because this is Hack AI, is our new AIQC mechanism. So essentially, right now, the way that it works is that, let's say out of 1 in every 100,000 images, you have some sort of an error, right? There's a bad camera removal, you group the brackets badly, and it looks, all ghosty and weird. Those are still delivered to the clients. You have to deliver to the client within a specific time frame or else they get mad at you. So you have to deliver it to the client. So what you can do is just as soon as a photo is processed, have some team that's sitting out there literally just scrolling through every photo, looking for bad edits, and then when they catch one, go back, edit the photo, deliver it, right? That is our current mechanism. There's a number of disadvantages to this. The first is that obviously we're still delivering these photos to the client, so if they look at the platform before we've delivered that human edit, then they still see the bad edit, right? They'll see that we've re-edited it, which is good, but they still see the bad edit, which is not what we're really looking for. The second is that it's often a very slow process, so we have a very big human editing team at this point, but even with that size, it still takes a long time for every single edit to actually come through. So you're not going to catch every error, and then on top of that, it's going to take a while to actually deliver that to the client. So what we built is, hence the word AIQC, is an AIQC mechanism. So essentially, after each inference job has successfully run, after we've gone through every microservice, we've run the core inference pipeline, et cetera, we then run just a really simple passover, right? Is there a grouping error? Is there a bad camera removal, et cetera, right? We find those errors and then we flag them. Right now we're working on actually, automated editing. That's a whole separate phase that's much harder. But the very simple mechanism of just catching those bad edits and being like, hey, we know this is bad, we're working on it. That's what we've done thus far. So in terms of actual value to you guys, there were kind of 3 different main iterations of the platform that we worked with. The first was using a very big text image to text model to try to catch those errors. Just one big prompt, one big model, try to rely as much as possible on the advantage of a large reasoning model. this did not work very well. It just was not very accurate, and it just ultimately did not work very well. So then we tried to split each prompt into exactly what we're looking for, right? Bad grouping, bad camera removal, etc. This worked, but it was very expensive, right? These large reasoning models per request, especially when you're sending gigantic images through, it is very, very expensive, especially per image at the scale that we're at. So the last version is using a small text image to text model and essentially doing the exact same granular prompting, right? So it's like 6 different prompts that we're looking for, try to catch a specific error, and if we catch it, flag it, move on. This costs anywhere in the range of like 3 to 5 cents per photo. We can probably get that down even further. But at this current iteration, it's, you know, relatively inexpensive, at least inexpensive enough for us, and it works fairly reliably. And then we don't have to ship bad images to customers, or at least we can tell them we shipped a bad image to them. And eventually we can work on fixing it. So this is just a quick example. You can see before inference, it's kind of probably hard to see on that. You can kind of see it. You can see that there's all those telephone poles. Our inference model flagged those as cameras and removed them inaccurately. Flag it, tell the customer, hey, we're working on it, move on. So that's kind of the core concept. Again, this is the kind of essence of our like whole pipeline. Kind of key takeaways, again, build scalable microservices, don't put the entire thing in a big ass container. And then second, use granular prompting and use very small models to get the same results as a big model and a big prompt. So if you want to come work for us, scan the QR code or email Jacob. He'll hit you up. Yeah, we're hiring pretty aggressively, so we'd love to have you. Yeah, that's basically it.
Does anyone have any questions?
Yeah, I was just wondering, do you guys only use prompts, or do you guys also like fine-tune models and distribute it like that?
Yeah, our core inference model is proprietary. So like our core inference model, we train from scratch, et cetera. And then all of the microservices are, you know, none of them are using, you know, any of the kind of big providers. They're way too expensive and they just don't have the returns. Funny enough, actually, probably like, I'd say a good, 7 out of the 12 are not machine learning at all. They're just basic algorithms. There's a number of things that we do that are just kind of like real estate specific, right? So it's like, oh, you know, we want to do perspective correction, for example. You know, this person takes an image like this, put it like this. Bunch of that kind of stuff. So yeah, most of it is just using small open source models, and then the core inference model, like I said, is a model that we train from scratch.
Hey, I have a question about your new solution. Do you actually save money now compared to before, and how much?
It's probably in the ballpark of, I don't know, we're probably spending a little bit more money running AI QC than we are running human editors, but again, it's worth it. I had this on the slides, but I just didn't talk about it. The other thing that's really good is that per customer, you know, different people are looking for different things, right? Like, there's this one big client of ours that's like, oh, we want the toilet seat down in every image, right? And so it's like, for that kind of specific stuff, you can then do AI QC, find all of those, re-edit the image so that the toilet seat's down in every bathroom shot, right? So it's like, it allows us to expand to like very specific things that we otherwise wouldn't be able to do. Because obviously we're not going to do that for every customer, because that'd be insane. But yeah, it's a little bit more expensive, to directly answer your question, but human editors are also expensive, and you have to pay them, you know, 24 hours a day. So yeah.
Quick follow-up. In the beginning, you had set up that you had models baked into Docker images. Could you share a bit more how you're thinking about, should you bake them into the image, or should you put them on object store?
Yeah, that's actually a little bit of a, are you saying in the monolithic setup or in the microservices architecture?
Both. When you're creating a Docker image, should you bake it?
So the model itself is cached on persistent volume. So the model itself is not necessarily baked into the image. I guess the like core runnable script is baked in, but then all the weights, all the stuff that's kind of heavy that we actually care about, all of that's persisted to a PVC and cached. So it's not as heavy as it otherwise would be. Before, this was before I worked for the company, so they, I believe, were baking the entire thing into the Docker image. It was like an 80 gigabyte Docker image, which is insane. So yeah, but yeah, as of right now, it's like the core runnable script is baked in, but then everything that's actually kind of big, we persist on a PVC. But, oh, there we go. It was too far.
Well, hello. Can you hear me at all? Okay, cool. Give one more round of applause for Sam. But a lot of what he was talking about is going to be really, really important, learning how to use different models for different applications, especially with the subsidization of AI coming to an end. Learning how to get more usage out of cheaper models is going to be really, really relevant. So take what he learned and apply it to your own practices. And then for our last speaker, we have Ford coming up. He's going to be breaking down some real world problems that he has gone through and solved on his own related to his taxes as an AI consultancy. So yeah, if you guys could all welcome up Ford with a round of applause. Yeah, I'd be on member, but you're already on member.
Choose the worst color in the background.
Oh, scroll up actually. Scroll all the way to its stuff. Ultra on Apple TV.
All right. Awesome. Happy 420, everybody. Woo! All right, so today I'm going to be going over how I use Claude Code to get majority of my taxes done. If you want to follow along with the presentation, there is a QR code to follow along. I'm going to be going a little fast because we only got the room for so long, so let's get into this. First things first, it's like the big thing we're going to be talking about today is really how to decompose a problem that you may have into steps, subagents, and the actual process that you want to use to flow through it to actually be able to build it. And then as a secondary thing, how to represent this within a file system to use something like Claude Code so you don't have to build a completely bespoke agent system for any problem you may have in your life. And the secondary thing is why taxes is really good for this is that everyone really has to do them. Whether you love it or not, it sucks, but you can have multiple income streams, a lot of accounts moving together, and when you do it right, you can save a lot of money, but it is also something that is very bad if you mess it up, because if you get audited, you need some level of traceability to actually see what happened. If you mess it up, that could actually mean jail time, loss of money, lots of things that you don't want. And before we get into it, my name is Ford Lascari. I'm an applied AI consultant and engineer, and I've been doing Gen AI for around 3 years now. And what I really like focusing on now is building these bespoke systems, giving a lot of observability into it, and now really focusing on applying this to my personal life, because I'm sure with a lot of you guys here, you've seen all these things like OpenClaw and other things actually promising you crazy gains back in your time, and really all you see is another subscription that you have to pay a bunch of inference to that's likely going to get more expensive. So how can we actually learn to reap those things? You might be asking me if you're on Twitter, Ford, doesn't Claude already do your taxes? And you'll be right. On tax day, they added a TurboTax plugin. And I'd done this a couple months ago, and I was like, well, shit. My entire presentation is all gone. But now, it didn't work out as well as they thought it would, because a lot of people were having a lot of issues with this, because usually when they were running this, it runs as like an MCP or a plugin, and then one agent runs the entire process and ends up doing a lot of processing on your documents, and it makes mistakes. And then the real problem is like when it breaks, there is no visibility about what went wrong. So when that happens, you don't know why it went wrong, and anyone that has built an agent knows it's not when things are going to break. Things break, and you need to be able to figure out how it broke and then go and fix it. So what we really need to be solving for is first, quality, making sure that all of the accounts and documents in your process actually have high accuracy when the documents go through. And the secondary thing is you need to trust the system that when things do break, you can then see what went wrong, or if in the case you get audited, you could then have some, here's what I did, here's why, and how can we go and fix it. And how do we achieve both? The main thing was a 4-step or 4.5 at this point process of first doing an intake interview to interview the user around what you do, and then understanding all the accounts and documents that you may have linked. We then extract all of those documents and process them into a AI readable format like Markdown. Then we go through and do another interview process to review any things the AI may have flagged. So this would be transactions that, let's say, a Uber on your business card, was that personal or business? You need to make sure of this. And then package that up to hand off to a CPA or to do it yourself. This year, I was a little hesitant on doing it, giving it all to the agent, so I gave it to a CPA. Next year will be probably full AI. But this ends up looking like a decent amount of skills, sub-agents, and then all put together to then be able to package that up in a Python script and then send back out into a Markdown and then XLS format. And then the first phase of this process is that first part of collecting your documents. Currently, you have to do that by yourself. So go through, collect all your bank statements, income, health insurance, or whatnot. One day, maybe we can actually get our little clanker to go do it for us. But for today, we're doing it ourselves. And then we go through and do an interview process to understand what each of these are, because let's say you have 4 different bank accounts. Which one's your business one? Which one's personal? Do you have one for groceries, et cetera, et cetera? And what that would look like here, dropping the files into the various folders so that then it is a good organization system for the AI, so it knows where you put things properly. And then it would go through and start interviewing you, asking you those questions, and then filling out a Markdown interview doc in the file system, so that is then able to have this to reference when doing the later steps. And then what this looks like in practice is after each question, it would then go and write to this Markdown file as intermediate steps, who you are, then what each of your accounts are, home office write-offs, whatever you have, and then going all the way through for all of the different sections that we have set up. Then phase 2 is where things really go wrong with the example that Claude did, is that when you have, let's say, 30 documents, if one agent is processing it, the context window gets very muddied. Each document can be like 20, 30, 40,000 tokens. So multiply that out, it likely won't all fit in. So the way to get around this is to spawn a sub-agent to process each of the documents and then aggregate across all of your sections. So in this case, that would go around like for each bank account, process out for the business, and then aggregate it into your total business income or expenses and such along that way. And this then looks more along the lines of, like, you can see each document that's a PDF, spreadsheet, anything that's like kind of hard to parse, you can give that to an AI, process things out, we aggregate those all together, and then write them out into a final document that then is used for the next phase of interviewing yourself. But this is generally what it would look like, just showing you all the transactions, all these things that are now in a format that is very easy for a subsequent LLM step to understand. And then it would also show you things that it flagged. So like, what is this Upwork contractor, Uber rides, anything of that nature. And then the next portion of this would be reviewing every section with you. So that would be then going through, what was this purchase, what was it, and updating it's a memory around that. So in that file where it was like, what is this thing? It would then read that file, read your context, and then ask you a question, answer it, update the file, looking more along the lines like this, where each time it will read that personal context, ask the question, and then update a output document so that then it can turn that into a packaged output for you. This kind of looks like this, where it would then show, like, here are all of your total purchases across all of your areas of life. And then the final stage is actually packaging that up, because right now we have things in a Markdown format, which is great for an LLM or us to read, but if you're handing that off to an accountant or someone, or filing that, that's not really good in a classical accounting area, where you may want something in a spreadsheet to actually be able to hand off and work with, get some better aggregations across it versus just a Markdown. So essentially what happens here is the AI will then write a script to turn each of the sections into a XLS renderer. I don't really exactly know what happened in there, because AI wrote all of that for me, and then it will write a validation script to make sure all the numbers that you put in those Markdown documents actually appear up correctly, to then try to have that level of quality that you need to have. And this ends up looking something like this, where each of those final documents gets processed into these JSON objects. We then build that into a spreadsheet, and then also a secondary Markdown document to send as kind of a summary off to your tax advisor or to do yourself. And this is kind of what that final looks like, is here is everything you have. Here are the questions that may not have been resolved that you may want to ask your CPA, any extra notes and whatnot. And then the spreadsheet that we end up with is something along the lines of this, if it will play. Let's full screen that. So it's able to put together a pretty professional spreadsheet. And all of this, when I was running it myself, took me of time that I actually spent at the computer, around 30 minutes to an hour of the actual runtime. A lot of this was spent just waiting for AI to finish processing because there was a lot of documents to do and put together. But yeah, I think that is, oh, I gotta get off of that. The real takeaways are mainly that when you decompose a problem, you can actually get a lot more visibility and then break things down to the actual steps required to reproduce it and be able to have a nice paper trail to hand things off. Traceability is the key thing there. So in this case, since we're using Claude Code, everything's on disk. So whenever anything wrong happens, you can then look at the traces on disk. And bespoke will be generic every time, where these systems come out and they work for a large swath of people, but as things get more and more complex and more nuanced to you, they will start to fail, and then you will be back having to build it yourself. And if you want to actually see this run, use it yourself, there's a link on my YouTube where I go through actually running it, and the code is open sourced and linked in the description. Thank you, and any questions?
Thanks for sharing. I am starting to explore the skills and the MCP servers and the tools. And I saw you had a skills directory. Did you write the skill yourself and reference like tax information, or did you let the agent write the skill?
For this one, I largely, I use speech to text a lot on my computer, so I would just kind of talk back and forth and be like, this looks right, this doesn't. A lot of the things I was doing right now is just document processing and classification. I have built on an extra portion on this that is adding more actual tax advice from research that would go within the skill file, but largely the AI writes a lot of the skill files and such that I will use. And then you get the bare bones written out by the AI, and then you can optimize it a little bit on your own after that. But the big heavy lifting portions of it, the AI can do quite well, and probably, at least on taxes, much better than I can, because I don't really know much about it.
And then just one other thing. So I was looking at the Claude pricing API and the API that does token calculations. And I know Light LLM has a budgeting feature. Is there any cost controls on that you can plug into this workflow, so you can say, well, I want you to do my taxes, but don't spend more than H&R Block?
At this point, no. Granted, this was run on my Claude Code subscription, which is heavily subsidized. So honestly, spend more tokens doesn't really matter. But yes, that would be not super hard to go in there. But some of them, say the document processing pipelines, those kind of have a fixed cost. And but there would be better ways to do it if I would use a vision model or some OCR to actually pull things out. But I was trying to build this in the easiest way possible without having to maintain some separate code base. So essentially this entire thing was done with a few markdown files and 2 Python scripts that were just aggregating things together at the end versus an entire data pipeline.
We have time for one more question.
Did you actually submit the final numbers from your script for your taxes?
I used a CPA this year because I did this 2 months ago, but I have on my to-do list to run it against what the CPA said for this year. Next year, I'm probably going to not use a CPA because it was very expensive. And
what's your CPA cost? Mine's $1,500.
Yeah, it was around 1,500. So I'm
no way.
Nah, bro, no.
Well, can I get one more round of applause for Ford? And if you have any questions about how you want to break down any of your manual tasks into something that AI agents can do, definitely be sure to talk to Ford and check out his YouTube channel. It has a lot of really cool breakdowns into his thought process behind things. And as Reed said in the intro, he is really, really awesome at what he does.
Awesome. So we have the rest of the time, maybe another 30 minutes to hang out. Definitely come talk to Holly, try some Avro. Appreciate you all coming out and this community. So thanks again.
Hey guys, check, check. Hey guys, we're gonna wrap it up here. We just had a couple police officers walk in, not entirely sure what's going on, but just want everyone to be safe, and it is just about 8 o'clock, so we're gonna wrap it up. Appreciate y'all coming out. Be safe and have a great night.